All right, let's go ahead and I don't even know if I'm doing the screen share, but let's go over the whiteboard. So let's go over OS structures. So we have operating system services, user, what does it provide? An environment for program execution. Provides an environment for program execution. So like the user and then also, so user-oriented services that it provides. Let's serve system services, right? User-oriented services, right? And so what do we have here? We have CLI, command line interface, graphical user interfaces, and batch. What about program execution? Program execution, like loading, running, and terminating programs, right? I mean, think about processes are these programs are being run. The operating system is deciding when it's loading, when it's running, when it's terminated. I/O operations, right? I/O operations, right? And we're gonna put this that there we go. Um, this is going to be user interface. Sorry, user interface. User interface. These are all user interface. And then program execution, loading, running, and terminating. I/O operations, file system manipulation, right? So, like, think about CRUD operations and permissions. Permissions, right? Test, test, test. Yep, I'm good. Permissions, right? And then communication, right? Communication, like shared memory, message passing, right? These are all about communication. Error detection and debugging, right? This is also very important. Error detection and debugging. So these are all things that the operating system, they're user-oriented services. It's operating service for the user. And then system-oriented services, right? System-oriented service. So system-oriented services, like think about the other area where it's resource allocation, right? We look over here. What is an OS? It's a program controller and a resource allocator. It should be a resource allocator. It's a resource allocator. It allocates resources to programs. Says, here you go. Here's memory. Here's CPU time. Allocating hardware resources to the process or the program, right? System-oriented services. Um, so we have resource allocation, which is obvious. So, if we think about it like CPU, memory, and like I/O devices, right? Okay. So there's there's resource allocation there. Accounting, tracking the usage, right? Protection and security, like uh like access control and auth or authentication, really. Authentication, right? So that's with the user-oriented services and system-oriented services. Now we're going to get into the third OS structure that we want to talk about, um, user interfaces. How does that, you know, what's the sort of the main, how like from an operating system standpoint, what do we think about when we think of user interfaces? Like, how do we interface with the operating system? Well, CLI. mainly. A lot of times it's CLI, direct commands implemented in a shell. It's flexible to Unix style. And then you have the GUI, the graphical user interface, right? So, um, Windows, Mac, Linux, KDE, GNOME. Those are your GUIs. I'm on a Mac M1 right now, so it's Mac OS whatever. That's the GUI, the graphical user interface. And then we also have like touch and voice interfaces. Touch and voice interfaces. So like gestures, virtual keyboards. And so I mean these are all, more niche voice commands. So okay, let's move on to some more meat and potatoes here. Syscalls, right? Syscalls and APIs, right? It's the interface between programs and OS. It's usually accessed via APIs. And you think, oh, APIs, oh, hitting up a web API or something like that. No, no, no. No, we're not talking about that. We're talking about Win32. We're talking about Win32 for Windows. We're talking about POSIX for Unix. I can spell Unix, Linux, right? And then Java API for JVM, Java API, right? For JVM, Java Virtual Machine, right? Okay, advantages of this, right? Portability and simplicity. Portability and simplicity, right? How do we do this so it matches up with like how we think as as people, right? Advantages of portability, simplicity. It's because of the API, the application programming interface, right? It's a way to interface with the program, right? Syscall implementation, calls identified by numbers and handled by syscall interface, right? Parameter passing via registers, memory tables, or stack, right? And then we're getting back into the memory, how it's organized, right? Registers are your quick, they're with your CPU, has those registers. And then think about the stack, think about, maybe it takes longer for that memory. The parameter passing. All right. Now we go to types of syscalls. So this is the next thing. Types of syscalls. Process control. Process control, file management, device management, information maintenance, communication, and protection. All right, so if we think about this, process control, it's like creating, terminating process, loading and executing, waiting, um, allocating memory, synchronization, right? I think I have it here. Do I have it here? Yeah. No. Process states, right? These are things that the operating system is focused on managing, right? And so it's managed in the API, or the way you interface with that is with system calls. So you can do process control, file management, device management, information maintenance, communication and protection, right? Right? We're gonna get rid of that. All right. So we got some good stuff here. protection, permissions, access control, right? Kernel mode versus user mode. Kernel mode has higher privileges than the user does. But the OS has to manage that, has to make sure that it's protecting that when you as the user are running your program, you're running in user mode. You are not going to run in kernel mode. Now, when you call malloc in your program, and you think, oh, well, that must be a system call. Not necessarily. Not necessarily, because the operating system will decide whether it needs a system call, like an nmap. All right. System programs. They provide a convenient environment for development and execution. All right. And then you do categories, right? Just kind of like what we talked about, right? File management, status information, file modification, programming support, right? Background services, right? All that, right? I'm just going to do like same as above, right? Just look at that, look at above, right? OS structures, or let's do OS design and implementation. Because I mean that is at the end of the day what this is all about. Is like why do you learn about OSs? Well, you learn so you can understand computing better. Yeah, but don't we all just want to build our own OS? Don't we all just want to be able to say we built an OS? I mean, come on now. Let me see if I can get rid of this. Okay. So, all right. So OS design and implementation, right? User goals, user goals, and system goals, right? They are two different things. User goals, convenience and safety, right? That's the main ones, right? Convenience, is it easy to work with, and safety. System goals, system goals, system goals, maintainable, flexible, efficient, reliable. These are things that are really important to the system. But convenience, safety, speed, reliability, right? We can do speed and reliability here too for user goals, right? That's cool. That's something we want. You know, separate policy from mechanism, right? That's the principle, right? So we can actually highlight this, or we can bold this, right? Principle, right? Separate, separate policy, separate policy, the what from mechanism, the how. How is it done? All right. That's how we should design, implement an operating system. So it's an implementation. I'm still bold. It's an implementation of a mix of assembly, good old assembly, right? C and C++. I can't type. C and C++ and scripting, like some Python and whatnot, right? All right. OS structures.